Over the last couple of years, Cisco's worked closely with our financial trading customers to understand their requirements and to engineer a solution specifically designed to meet their needs. These requirements included ultra-low latency to allow them to execute more trades faster, enhanced performance visibility with the tools to optimize data flow and latency, and line rate network address translation to enable them to do business in any trading venue. To meet these requirements, we needed to design a completely new switching architecture from the ground up just for high-performance applications such as high-frequency trading.
To develop Algo Boost technology, we had to think out of the box and take a different approach than the industry about the way ASICs are designed in order to optimize the port-to-port latency. Historically, switching ASICs are designed with serial internal pipelines to process data and apply services. Processing data via a serial pipeline approach makes for simple designs. However, it adds latency at each stage. The challenge we had to solve was how we can deliver all the necessary services while dramatically reducing the port-to-port latency. The solution we came up with is parallelism. That is, doing multiple tasks in parallel with fewer clock cycles. Cisco Algo Boost technology essentially executes multiple functions in parallel, significantly reducing latency. While the packet is entering the ingress port, the packet header is split into pieces, with each being forwarded to the service's processing blocks in parallel. This means the service processing begins even before the entire packet has been received into the switch, further reducing latency. Using these design principles, we were able to achieve latencies of around 250 nanoseconds for Layer 2 and Layer 3, unicast and multicast, regardless of which features are enabled, including network address translation. But we weren't done. We know we could do better than 250 nanoseconds. Our engineers came up with another innovative solution, storing different types of data in the same table. This allowed the switch to do multiple functions with a single lookup operation, resulting in an additional 20% reduction in port-to-port latency. We named this warp mode.
Lowering the processing latency wasn't the only challenge we had to solve. In real-world trading, network microbursts and congestion can be an issue during times of market volatility and heavy trading.
Congestion detection was a particularly interesting problem, since congestion can build and drain in milliseconds or less. Since today's buffering monitoring solutions are all software dependent, they end up missing many of the short congestion events that can delay trade execution. So our engineers came up with yet another innovative solution: build monitoring into the ASIC itself so we can poll for congestion at a much higher frequency. And since this creates an enormous amount of data, with thousands of data points per second, we chose to implement a histogram model to simplify analysis. We also allow users to set thresholds, so they are notified if buffer usage exceeds a specified value. With congestion detection built into the switch, we added tools to simplify and correlate timing of traffic events to network events. We added logic to timestamp every packet as soon as it enters the chip. And we added cleanup logic to allow for filtering, sampling, and truncation of span data.
Algo Boost technology shows Cisco's clear commitment to delivering business-driven innovation to our customers. Our deep pool of global engineering talent and over $5 billion in research and development allow us to set the pace of innovation in the industry. Since we develop our own ASICs, we can directly execute on what our customers are telling us. The Nexus 3548 is the first switch to feature Cisco's Algo Boost technology, delivering performance, visibility, and control for greater business agility for our financial customers.